Alright, so in this problem, we are asked to determine of these choices which ones are equivalent to the integral from -3 to 3 of x sine of x dx. So let's look at A first. So this one is not equivalent. So x sine of x, it turns out, is actually positive on this interval. So area under the curve can't be 0. So how do we know it's positive? Well, sine of x is positive between 0 and pi, and 3 is less than pi, so sine of x will always be positive if x is positive. So that means when x is positive, they're both positive. Sine of x becomes negative between 0 and negative pi, but then this x out front is also negative, so then the two negatives will cancel. So either way, on this interval, this function is positive. So definitely the integral cannot be 0. Now let's take a look at this one. Turns out this actually is equivalent, so to see why, let's rewrite this. It's the integral -6 to 3 plus, or actually, let's see here, -6 to, okay, right. So integral -6 to 2, I guess I should say first. Let's split it up into more steps. Plus integral 2 to 3 minus integral 3 to 6. So if we rearrange these things, then we'll get that this is the integral -6 to -3 plus the integral -3 to 3 minus the integral from 3 to 6. And then we have the integral that we want, and then these two integrals on either side. But because the function is even, we'll show this in a minute, these two integrals actually cancel out. They're the same area. So that means we're just left with the integral from -3 to 3, which is what we wanted. So basically the idea here is to use the property that you can split up the integral. For example, like integral -6 to 2 plus integral 2 to 3 is the same as integral -6 to 3, and so on. And you just use that property several times to eventually arrive at this. So next is this one. This is equivalent. And so how do we see that? X sine of x is an even function. So we know that if it's an even function, then this would be true. We can change the integral from -3 to 3 to 2 times the integral from 0 to 3. So let's see why it's even. Well, that's because -x times sine of -x, this would be f of -x, is equal to sine of -x is the same as negative sine of x, and then the negative signs cancel, so we just get x sine of x. So what we've shown is that f of -x is equal to f of x for any x. That means the function is even. This one is not equivalent. Basically what happened here is they, I guess, tried to do an antiderivative and screwed it up, but at any rate, this is definitely not the same. If you really want to convince yourself of this, you can calculate that this is the same as 6 cosine of 3. Cosine of 3 is really close to cosine of pi, so it's actually a negative number. And we already said that the function we're integrating is always positive, so definitely this cannot be true. So then we come to this one. This one actually is equivalent. So this is equal to negative integral -3 to 3 x sine -x dx. Since sine of x is an odd function, this is the same as positive integral negative 3 to 3 x sine of x dx, which is what we wanted to show. Then lastly, we have that capital F of x is an antiderivative of x sine of x, and this is by FTC2. So by FTC1, we have that f of 3 minus f of negative 3 is the same as the integral negative 3 to 3 of x sine of x dx, as we wanted. So this one is also equivalent. So basically, the idea of this problem is just to apply properties of integrals for an even function to determine which of these things is the same as the integral that we started with.